Good morning, children. Welcome to One Mark Solution. Please subscribe, like, and share. Now, let us start with Magnetic Effects of Electric Current, Chapter 13. We'll go for Assertion and Reason. Electric current, I told you, it's very important. Like that, we can say the effects of electric current also is important. So, let us start with the effects of electric current. The first one is magnetic effect. And you know that, isn't it? First observed by OERSTD, Easterd. From Easterd experiment only we got that magnetic field is produced due to current carrying conductor. Now let us start with the first question. Safety fuses are made up of materials having low melting point. Sure. What if it is correct? You just think it of fuses. Fuses is necessary for us, isn't it? Why? Because if anything happens, high current is coming, what should be there? The fuses will melt. That means the connection will be break, isn't it? So that we will be safe. Safety, the reason we can go for it, safety fuses should be resistant to electric current. You just think it of whether assertion and reason is correct. Both are correct? No. Assertion is correct. That means it should be low. If it is a high melting point, what will happen? When high temperature only, it will melt. So that the current will flow through our devices and it will damage, isn't it? So that is why usually we will use the low melting point. And what about the reason? Safety fuses should be resistant to the electric current. Is it correct? No. So that is false, we can say. So the option is C. So you should know about the safety fuses also. Now we can go for the second question. Assertion. On freely suspending a current carrying solenoid, it comes to rest in north-south direction, just like a bar magnet. You know what is bar magnet? It's having north and south pole. So if you are suspending a bar magnet freely, what will happen? Always it points north-south direction, isn't it? That is how we can find the direction. In olden days, there is no devices to find the direction and all. So what they are doing is with this bar magnet, that means with a magnet, leading stone is there, lodestone is there, right? They will just suspend like this and they can find north and south. If they are getting north and south, other directions also we get it. So that is why in olden days we'll call it as leading stone, lodestone, right? Now we can go for this. Assertion is absolutely correct. Now we'll go for the reason. One end of the current carrying straight solenoid behaves as its north pole and the other end as a south pole. Yes, that is why it is always pointing north-south direction. So here assertion and reason are true and the reason is the correct explanation for the assertion. One more thing I want to point out. When a current is flowing through the conductor, that means straight solenoid or any conductor, what will happen? We will get magnetic field. That is why if they are getting magnetic field, one end will be act as north pole and the other will be south pole, just like a bar magnet. So here the answer is A. Now we can go for the next one, third question. Assertion. Copper is used to make electric wires. This already we have discussed. Just think it of. Copper is used for making, electric wires. Why? What is the reason? Copper has very low electric resistance. If resistance is low, what will happen? Conductivity will be more, right? So the assertion and reason are absolutely correct. And the reason is the correct explanation for the assertion. This is very simple. You will think it's very simple. All of you know that. But don't make mistake also, right? So here the option is A. Now we can go for that fourth question. Assertion. A compass needle. All of you know that a compass needle, isn't it? A compass box will be there. Inside one needle is there. It is made up of magnet. So magnetic needle we can say is placed near a current carrying wire. So here a current carrying wire will be there. If you are placing near that current carrying conductor, that needle will be placed. What will happen? The deflection of the compass needle decreases when the magnitude of an electric current is increased. No. What will happen? Deflection will be increases. When the current increases, we know that when the current increases, we are getting more magnetic field. So the needle also deflects more. So the assertion is not correct. It is false. Please keep it in mind. When the strength of the current increases, deflection also increases. When the direction of the current is reversed, the deflection also gets reversed. All that depends. Magnetic field depends on the electric current. Now we'll go for the reason. Anyway, assertion is wrong. That is false. Reason. The strength of the magnetic field at a point near the conductor increases or increasing in current. That is absolutely correct, isn't it? When the current increases, the strength also increases. So the reason is correct. Reason is true. So which is the option? We can say option B, right? A is false and reason is true. Now we can go for the next one. That is fifth question. AC load line. What is AC? Alternating current. Alternating means it is always changing up and down. That means positive and negative, up and down, it is changing. Is used for long distance transmission. Yes, we are using alternating current. We are producing alternating current and we are transmitting also. And why long distance transmission we are using? You take an example of a transformer. What is the use of transformer? We have to increase or decrease the voltage. In the case of the transformer, we know that there are two coils. So mutual induction have to take place. If you are giving DC, what will happen? There won't be no change in current, no change in magnetic field. You know what you mean by electromagnetic induction, isn't it? Whenever there is a change in magnetic field, then only an EMF is induced. So here in the transformer, if AC is passed, then only it will pass to the output. Otherwise, if you are giving input, it will stay input only. So that is why in transformer, we are using one of the phenomena of electromagnetic induction, that is mutual induction. For long distance transmission, we are using only the AC, that is alternating current. What is the reason given here? We can see it has very less loss of energy in long distance transmission. That is absolutely correct, isn't it? So A and R are true and R is a correct explanation of A. In between, I told something that is also very much important. You should know that what are things is happening in our daily life, isn't it? With the help of electromagnetic induction only, all this is happening. We are getting current, the production of the current, not only the production and the transmission also takes place. So here the answer is A. Both A and R are true and R is the correct explanation of A. Now we can go for the sixth question. When two bulbs are operated on the same voltage supply, having power 60 watt and 100 watt, then 100 watt bulb has less resistance than 60 watt. This already we have discussed. Power is equal to V squared by R. When power increases, resistance will be less. Here we can say 100 bulb, that is 100 watt. Power is more in 100 watt, isn't it? So they have less resistance than 60 watt. So the assertion is correct. What about reason? The power of the bulb is directly proportional to the square of the voltage. Think it of. The power of the bulb is directly P is equal to V squared by R. So power is directly proportional to square of the voltage. Correct. So here we can say assertion and reason are true. But can we say the answer, that means reason is the explanation of the assertion? No. Why? Because in the reason we should have written, what is it? The relation between resistance and the power. Here it is written the voltage and the power. So that is why it is not the correct explanation of the assertion. So which is the option? Option B. Now we can go for the seventh one. The magnitude of the magnetic field at a point on the axis of a current carrying solenoid is inversely proportional to the current flowing through the solenoid. Just think it off. What is it? Magnetic field is inversely proportional to the current flowing through the solenoid. No, it is directly proportional. When the current increases, the magnetic field also increases. So assertion is wrong. Assertion is false. Now we can go for the reason. The magnitude of the magnetic field at a point on the axis of a current carrying solenoid is directly proportional number of turns per unit length of a solenoid. I'll tell the equation also. B is equal to mu 0 Ni. Mu 0, that is a permeability of free space. Mu 0 Ni. N is the number of turns per unit length. So B is equal to, B is the magnetic field. So it is directly proportional number of turns. When number of turns increases, magnetic field also increases. So the reason is true, but the assertion is false. That means it is not inversely directly proportional. So which is the option? Option D. Now we can go for the option, that means assertion reason D. Assertion. An induced EMF appears in any coil in which the current is changing. That means induced EMF means what is it? During the process of electromagnetic induction, we can say an EMF is induced in any coil. When the magnetic field is changing. When we can say magnetic field is changing, current is changing, right? So the assertion is correct. Now we can go for the reason. Self-induction phenomena obeys Faraday's law of induction. Self-induction is also a process of electromagnetic induction. Two processes you have to study under the heading electromagnetic induction, the self-induction and mutual induction. Self-induction, the word itself, you know that self, they're inducing by itself. Whenever the current is changing or the magnetic field is changing, EMF is induced by itself. That is why we'll call it as the process self-induction. So here, what is that? Assertion and reason are true, but can we say the reason is the explanation for the first one? No. They are telling, reason is telling about the self-induction. And the first one is electromagnetic induction. So the answer is B, the option B. And all of you should know that who introduced electromagnetic induction? Who introduced this one? Faraday. And you know that Faraday is the father of electricity. Always when you are using current, please, thanks to Faraday, right? Yes, now we can go for the next one, 9th question. The magnetic field produced by a current-carrying solenoid is independent of its length and cross-section area. See that? Magnetic field produced by current-carrying solenoid. Solenoid or any conductor will produce magnetic field when current is passed. But it is written here, it is independent of its length and cross-section area. Absolutely correct. Why? Because it depends on how much the strength of the current and the number of turns and the media inside the solenoid. All of you know that solenoid, isn't it? What is a solenoid? You will say like this, a coil, isn't it? Coil, that is correct. But the length is very large and radius will be very small. So here we can say it depends on current, number of turns and the medium inside the solenoid. So here it is not correct or correct. It is independent. Correctly, the assertion is absolutely correct. Reason. The magnetic field inside the solenoid is uniform. Can we say this is the reason for assertion? No. But this is true also. Inside the solenoid, the magnetic field is uniform and it is very strong inside the solenoid. Outside is very weak. That also keep in mind. Okay. But it is not the explanation for the assertion. So what is the answer? The option B. Now we can go for the 10th one. The magnetic field is stronger at a point which is nearer to the conductor and goes on decreasing on moving away from the conductor. Yes, the magnetic field B produced by a straight conductor carrying wire is inversely proportional to distance from the wire. That is absolutely correct. When the distance increases, magnetic field also, what is happening? Distance increases, magnetic field decreases. That means B is equal to, the equation I will say, equation you will study later, B is equal to mu 0 by 2 pi I by R. That is B is inversely proportional to R or B is proportional to 1 by R. When R increases, magnetic field will be decreasing. That you know. So what is the answer here? We can say both A and R are true. But can we say R is the correct explanation? Yes, of course. That is why goes on decreasing on moving away from the conductor means what is it? Distance is increasing. So the reason is the correct explanation for the assertion. So which is the option A. Now, thank you for watching. Please go through the concept clear and what is the dependence of the current and the magnetic field. You should know that. Then only you can answer of these questions. Thank you once again.